Good morning, welcome to your Wednesday maths lesson. Today again we're continuing with fractions and we're going to be looking at adding two or more fractions. Okay, so here is our first fractions addition. We have 3/5 add 1/5. And here we have a girl with a statement and she says that's easy. 3 plus 1 is 4 and 5 plus 5 is 10. So the answer is 4/10. Right, let's have a look at some bar models to see whether she is right or wrong. So, here you can see a bar model that is showing 3/5, which is the first fraction in our calculation, and then we need to add 1/5. Now, what we can do with that 1/5 is we can simply put it into our first bar model, get rid of that one, and we can see that we now have 1/5, 2/5, 3/5, 4/5. So 3/5 plus or add 1/5 is 4/5. So this girl is incorrect because what you might see that she's done is she has added not just the numerator but she's also added the denominator. She has added the fifths to give her 10, which is incorrect. So why is it that we add the numerator but not the denominator? Well, the denominator is like the unit or label we are dealing with. So for example, if I was saying there were 20 children in the class and then 3 children joined the class, children would be the unit and our answer would be 23 children. So we know that if we did 3 apples plus 1 apple, it wouldn't give us 4 bananas. We know that 3 apples plus 1 apple is 4 apples. So when we're adding fractions, you do not add the denominator because that is simply the label or the unit we are dealing with. Okay, so here is your first mini task. The question says, Eva eats 3/12 of the donuts, Amir eats 4/12 of the donuts. What fraction do they eat all together? So we know that our equation is 3/12 plus 4/12. So pause the video here and then when you come back we'll go through the answers together. Okay, so here we have 12 donuts. We know that 12 out of 12 12/12 is 1 whole. So that is our box of donuts. Our box of donuts equates to 1 whole. And 1 donut equates to 1/12. So if we were doing 3/12 plus 4/12, we know that 3 add 4 is 7. So our answer is 7/12. Eva and Amir ate 7/12 all together. They ate 7 out of the 12 donuts. Okay, let's have another question. Sorry, a look at another question. So here we have 2/8 add 3/8. So let's have a look at this on a bar model. So here is our bar model. It is showing the 2/8, and all we have to do is add the 3/8, and the answer gives us 5/8. So as you can see, we've only added the numerator. We've done 2 add 3 equals 5/8 because here the unit we are dealing with is eighths. Okay, let's have a look at another fractions addition. So here we have 3/5 add 4/5. Now you might notice something about this answer that is different. So here are our 3/5 and then we're going to fill in the final 2 and that is adding on 2/5, but we need to add on 4/5. So we need to add another 2/5 to this. So we would draw another bar model and draw the extra 2/5. So now you can see we have 3/5 in green and the 4/5 demonstrated in yellow. And if we add them all together, we can see that we have 7/5. Now, as you can probably see, 7/5 is an improper fraction, meaning that the numerator is greater or bigger than the denominator. So we could even either leave this as a fraction, 7/5, or we can turn it into a mixed number, which would be 1 and 2/5. So either one of those answers is correct. 7/5 is the same as 1 and 2/5. Right, Year 5, here is another mini task for you to be getting on with. So you can see that there are 4 different fraction addition equations here. The first one, I've given you the bar model showing the sevenths. So if you want to use bar models to help you, you will need to draw those, but that's the first one's there for you. So some of these are the simple addition that we've been doing, and some of them are missing number questions. So pause the video here, get your pencil and paper, and have a go at these questions, and then we will go through the answers together. Pause it now, come back when you're ready to hear the answers. Okay, so question 1, we have 3/7 and 2/7. So what we're going to do is draw our 3/7 in yellow, but we need to add 2/7, so they are now in blue, and we can clearly see that altogether we have 5/7. Right, so our next question, we have 3/8 add something 8 to give us 7/8. Now we know that we don't have to add up the denominator, so all we really need to work out is 3 plus what, 3 add what equals 7. And we know that 3 add 4 equals 7. So now we know that 3/8 plus 4/8 equals 7/8. Okay, let's have a look at this one in the bottom left. We have 3/5 plus 1/5 plus 4/5. So this is just the same, it's just that we're adding 3 fractions, not 2. So as you know, we don't have to add the denominator because fifths is the unit we are dealing with. So we would do 3 plus 1 plus 4, which we know is 8/5. And we can also see that this is another improper fraction where the numerator is greater than the denominator. So you could leave it as a fraction, or you could turn it into a mixed number. And we know that 8/5 would give us 1 whole, because 5/5 is 1 whole. And when we would have a remaining 3/5, so 8/5 is the same as, or equivalent to, 1 and 3/5. Okay, moving on to our final question. What we have here is the answer, and we have a missing fraction. So we have 1/6 plus 3/6 plus something 6 gives us 1 and 1/6. Now the best thing to do here would be to turn that mixed number into an improper fraction. So we know that that whole is 6/6, and we also have 1/6. So that answer is the same as 7/6. So we have 1/6 plus 3/6, that gives us 4/6, but we know the answer is 7/6, so we need to do 4 add what equals 7, and we know that 4 add 3 equals 7. So, well done, those are the answers to those 4 questions. If you got any of them wrong, do not panic, just have another look at the answers and listen to my explanation and see where you went wrong. Okay, here is a question that is quite similar to the last one you did on the previous slide. So we have something ninths plus 2 ninths equals 1. So what do we know about the number 1 in this case? It's the whole. We know it is essentially 9 ninths equals 1, or the whole. So what this question is asking us is how many ninths plus 2 ninths equals 9 ninths. So we have the 2 ninths, and all we need to do is fill in the rest of the bar model to give us the whole. So we know that in blue we have 7 ninths. So we know that 7 ninths plus 2 ninths equals 1. So this is just another way of looking at fractions addition. Okay, year 5, here is another 2 questions for you to do based on what we've just learned in the previous slide. So pause the video here and fill in the boxes in questions 1 and 2. Okay, so question 1 says, how many 11ths plus 7 11ths equals 1? So we now know that the 1, or the whole in this situation, is 11 11ths. So all you need to work out is 7 plus what equals 11, which you have here. So shaded in green is the 7 11ths you already have, and then in orange you can see that the remaining we need is 4. Okay, number 2. So 1/8 plus how many eighths equals 1? So in this situation, your whole would be 8/8. So we have 1/8, which is coloured in yellow, and then we have the remaining 8ths in grey. So we know that 1/8 plus 7/8 equals 1. Okay, so far we've looked at adding fractions where the denominators are the same. But what do we do if the denominators are different? So what we do is really quite simple, is you use your knowledge of equivalent fractions to make them the same. So to make the denominators the same. So we have 1/2 plus 1/3. So the denominators are different here, but we know that a common multiple of 2 and 3 is 6. So for each fraction, we need an equivalent fraction with a denominator of 6. So 1/2 we need to make into 6ths, and we know that 1/2 is equivalent to 3/6 because 3 is half of 6. And 1/3 we need to make into 6ths, and we know that double 3 is 6, so times by 2. So doubling 1 times 1 by 2 gives us 2/6. So we've therefore made our sum much easier because now we have the same denominator. So we will do 3/6 plus 2/6 equals 5/6. Right, let's have a look at another one. We have a 1/2 plus a 1/4. So those both have different denominators, but we could definitely convert these fractions so they are both quarters. So we'll keep the 1/4 as it is, and all we need to do is, so we're going to keep this 1/4, and as you'll see we've made this into 2 quarters because we know 1/2 is equivalent to 2 quarters. So we've done 2 times by 2 equals 4, 1 times by 2 equals 2. And then that gives us 3 quarters. So 1/2 plus a 1/4 equals 3 quarters. Okay, year 5, here's one for you to do. So you have 2/5 plus 3/10. Now, what I would suggest you do is that you turn the first fraction, your 2/5, into tenths. How could you turn fifths into tenths? Pause the video here, have a go, and then unpause and we'll go through it together. Okay, so what we've done here is we've taken our fifths, and to make them tenths, we have doubled the fifth, times it by 2 to make it a tenth, and what we've done, we then have to do the same to the top, so the 2/5 becomes 4/10. So then we know that 4/10 plus 3/10, 4 plus 3 is 7/10. Okay, here's another one for you to do. So you have 2/3 plus add 1/12. what could you turn one of these fractions into to make it easier for you to add? Pause the video here, have a go, then press play and we'll go through it together. Okay, so we have 2/3 and 1/12. Let's make both fractions into 12ths. So, what do we do? 3 multiplied by what equals 12? Now, by now, we're pretty good with our multiplication facts, so we know that 3 multiplied by 4 equals 12. So we'll multiply this 3, this third, by 4 to make it a 12th. So therefore, we need to multiply this 2 by 4 to give us 8. So we now have 8/12 plus 1/12 equals 9/12, or 3/4, because we've simplified it down. Okay, Year 5, it is now over to you. You have a worksheet to do about adding fractions. Now, if you get stuck at any point, just come back to this video. The first half of the video, or the majority of the video, is about adding fractions with the same denominator. And then you have a couple of questions about adding fractions with different denominators. But do not panic. All you have to do is use your knowledge of equivalent fractions to make those fractions have the same denominator. So, if you get stuck at any point, as I said, come back to this video. Good luck. I'm looking forward to seeing your work.